Nature does not hurry, yet everything is accomplished. Lao Tzu, in 1997, a fire in Indonesia raged for nearly a year. It spread across thousands of square kilometers, disrupted international flights, and sent a dense, acrid haze as far as China. Yet for months at a time, this massive fire burned without producing visible flames. It was blazing entirely underground. Fires like these, known as peat fires or zombie fires, are surprisingly common. Each year, they contribute about 15% of global greenhouse gas emissions, more than 6 times what international aviation produces. These underground blazes are incredibly persistent, making them nearly impossible to extinguish. But how do such fires form, and is there any way to stop them? For any fire to ignite, 3 key ingredients are needed: fuel, heat, and oxygen. All fuels have an ignition point, which is the temperature they must reach to start breaking down. This process, called pyrolysis, releases gases that combine with oxygen to create combustion. The chemical reaction produces heat and light in the form of flames. However, not all combustion results in fire. Pyrolysis also leaves behind char, a carbon-rich material that can smolder without producing flames. This slow, glowing burn releases smoke packed with pollutants like carbon monoxide, methane, and particulate matter. Peat fires form in carbon-rich soil called peat, which develops in cold or wet regions where organic material builds up faster than it decomposes. These peatlands act as massive carbon stores, locking in the carbon absorbed by plants during their lifetimes. Historically, the wet and cold conditions of peatlands kept them safe from fire, but climate change has altered this balance. Droughts and human activities like draining peatlands for farming have made these areas drier and more flammable. When surface fires ignite dried-out peat, they turn it into char. The smoldering fire spreads slowly, creeping through the soil at just 1 millimeter per minute. Over time, the heat dries deeper layers of peat, allowing the fire to burn downward. These fires are relentless, lasting for months or even years. They release vast amounts of greenhouse gases, choking nearby regions with toxic smoke. Worse, they're hard to detect since they burn below the surface, sometimes reigniting miles away. Zombie fires can even survive freezing winters, smoldering under snow-covered soil. Come spring, they resurface, sparking new blazes. Their ability to persist and spread makes them a major environmental threat. So how do we combat these underground infernos? Dousing them with water isn't as effective as you'd think. Peat is dense, and water's high surface tension prevents it from penetrating deeply. Scientists are working on ways to lower water's surface tension, making it more effective against smoldering fires. Controlled burns in peatlands and efforts to keep these regions wet are also promising strategies. Some countries have prioritized preventing peatland drainage altogether, recognizing how vital these areas are for storing carbon and mitigating climate change. Peatlands cover just 3% of the Earth's land, but store over 25% of its carbon. As climate change increases droughts and extreme weather, protecting these landscapes has become crucial. Stopping zombie fires isn't just about fighting a fire. It's about preserving one of the planet's best tools for keeping carbon out of the atmosphere. For more videos, please like and subscribe.